My screen is visible to all of you?
Yes, sir.
Okay. Let me open the chat book. So some of you may be new here. So first I'll introduce myself. I am Ravi Kumar. I'm a research scholar at IIT Bombay under PMRF scheme, and I am working on the field of photovoltaic technology, particularly on the reliability issues. So this is the second assignment, week 2. So first question is that what is the intrinsic carrier concentration in germanium at 200 degrees Celsius? If the effective mass of electron and hole is 0.3 mass times of mass of electron and 0.56 times of mass of electron. So mass of electron is what? How many? Do you know the mass of electron? 9.1 into
9.1 into 10 to the power of minus 31 kg, sir.
yeah, great. So take the energy band gap for germanium is 0.7 electron volt, and then we need to calculate intrinsic carrier concentration. So have you done it? If you have done it, then you can write your answer in chat box. If not, then ready with the copy and pen with the calculator. We will solve it right now. So I'll show you a formula and some constant used in that formula. You just need to put this constant in this formula and calculate it. So this is the formula to calculate the intrinsic carrier concentration. Just let me know what are the terms you don't know in this formula. ME and MH is given in the question already. EG is also given in the question. What else you know, need? Do you know what is this K?
Boltzmann constant, sir.
Yeah. And what about H?
Planck's constant.
Okay. So how, like, what will be the value of T here? T is the temperature here. What T is given and what will you put in the formula? Anyone? What
Ni.
T?
We
Oh,
have to
sorry.
find out Ni.
Yeah, you need to find out Ni. I am asking about T. What value of T you will keep?
200 plus 273.
Right.
473.
Great. So we need to convert it into Kelvin. So
Calculate.
these are some values. If you will put these values in this formula along with, so these are the values. If you will put two values like 0.31 here, 0.51 here into mass of electron 9.1 into 10 to the power minus 31. So Me and Mh will be this one. And after putting these values, you will get an answer. Can is anyone trying here or already you got the answer? If you are calculating, you can calculate right now. Otherwise, you can do it later. It's fine. Okay, then I am showing you the answer. If you are not solving right now, you can solve it later. But this is the formula which you have to use. Answer is 9.1 into 10 raised by 20 carriers per meter cube. You can check your answer with this, and if you have any difficulty, you can comment. You can ask in discussion forum, or you can ask in YouTube. Like I am uploading these videos on YouTube, and you can ask there as well. You can comment below the video. I'll give you some solution. Is it fine?
Sir.
Yeah.
Yes, sir.
Okay. Okay, then let's move to the second question, which is very easy and you have to solve it right now. A solar cell has a short circuit current 25 milliampere and open circuit voltage 0.8 volt. If the maximum power output was 15 millivolt, calculate the fill factor. Anyone? First, let me know the definition or formula of fill factor. Formula of this fill factor. Anyone? You know or not? Formula of this fill factor.
INVM upon ISCVOC.
ISC into
Yes.
VOC
Yes.
divided by PI.
Divide by
PI.
just check.
VM and IM.
So you are saying ISC VOC divide by this power output, right?
Yes, sir. Yes.
Then please calculate it. If you are saying VOC into ISC, then just multiply 25 into zero point 0.8 and divide by 15,
1.33.
1.33. So if you will say in percentage, it will be 133%.
133.
It means your formula is not correct. It should be otherwise, like PMPP divided by VOC into ISC. So fill factor will
Okay.
be this one.
Yes,
Now calculate again. Yeah, Suraj Kishore is right.
$75.
75%.
75% right. If you haven't calculated, then you can see on the screen. I hope it's clear. Okay, so let's move to the other question. So answer will be D. Fill factor will be 75%. Next, the attractive and repulsive Leonard Jones potential of atoms and molecules on each other varies with the distance between R as. So attractive will be the like watt power of R and repulsive will be watt power of R. Just you need to tell me the power. Pita is saying B, Suraj is saying D. What about others? Attractive and repulsive. Isha is saying this and Suraj is saying this. What about others? Okay, let me give you some hint. This from here it should be clear to you. So if this is the repulsive potential, so how much power of R here is?
All
And for the attractive potential, it is the power of it should be here 6. So for the attractive it is 6, for repulsive it is 12. So right answer is B. Okay, let's move to the next question. Which of the following material has the highest resistivity? Now you all need to like answer this question. It's very easy. You can write in chat box copper. Someone saying is
Sir, screen
copper.
is not visible.
tungsten.
Sorry, what is not visible?
Screen is not visible, sir.
Is it to everyone or like only some? Hello?
Yes, copper's highest resistivity.
Is it my screen is visible or not? Okay. So many students are saying visible. So it should be some network issue if it is not visible at your place. I'm saying which of the following material has the highest resistivity? And someone saying copper means highly resistive is copper. How it can be possible? Isha is saying quartz, Suraj is
Metals are
saying
good
quartz.
conductors, sir.
Yeah. So good
We do put
conductor should have
silicon.
least resistivity, na?
Hmm.
Okay. Quartz. Now
We do
people are
put silicon, sir.
sorry.
We do put silicon.
Ha, we dropped silicon. I'll give you the hint. See, resistivity of semiconductor like silicon is about 10 raised to power 10 times of more than copper. But the resistivity of quartz is 10 to the power 25 times larger than this copper. And p doped, what will happen here? Conductivity will be more as compared to silicon. For the p doped means it will further decrease the resistivity. What doping do? Doping increases the resistivity or decreases the resistivity?
Decreases.
So if resistivity of silicon is 10 raised to the power 10 times of copper and quartz is 10 to the power 20 times of copper, then who will have the highest one?
Quartz.
Yes, quartz. So correct answer will be this quartz. Next question. To make intrinsic germanium, a p-type semiconductor, we have to dope it with. First, let me know the valence electron of germanium.
4 electrons.
4 electron. If we need to make it a p-type semiconductor, so how many
8.
electrons it should be like doped with?
Third group element.
Trivalent.
Trivalence.
Third
Trivalence.
group element.
Then what are trivalents here?
Aluminum.
Boron, aluminium.
Yeah, great. Boron and aluminum. Yes. So correct answer will be A and B. Let's move to the next question. The potential in the depletion region is it constant, or it decreases from P region to N region, or vice versa from N region to P region, or is it zero? Okay, first let me know the depletion region. What is this depletion region?
The junction between P and N type semiconductor.
Okay, great. Then the potential in this depletion region should be constant, zero, or decreasing from P to N or N to P. Isa is saying C. Okay,
Yes, it is C. Decrease from
it should
NPTEL
C.
to BFTEL.
Okay. Now a figure is in front of you. You can see and then confirm it. Yes. Okay, C. So it decreases from N region to P region, like it is decreasing here. Okay,
C, sir. C.
C. Yes, great. Okay, then let's move to the next question. If a material has a band gap of 5 electron volt, it will be classified as
Insulator.
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 yes, insulator. Why? Because materials with the band gap more than 3 electron volts generally classified as insulators.
Semiconductor.
No, insulators. For the semiconductor, it should be like 0.3 to 3 or 0.1 to 3. So answer for this question is insulators, right?
Sir, for indium, sir.
For
Indium.
indium, what is the band gap of indium?
3.75 electron volt.
Yeah, that's why
But it is considered as N-type semiconductor.
yeah, that's why I'm saying generally. It may be 3, it may be 4 sometimes as well.
Okay,
That's
sir.
generally. And here it is 5 electron volt. Okay, so let's move to the next question. Question says materials which have completely filled valence band overlapping with partially filled conduction band are classified as
Metals.
metals or
Conductor.
conductors
Conductors.
or semiconductors or insulators. Yes, you can say metal or conductor are same. So answer will be this one is the valence band. It is saying filled valence band. So valence band is filled here. Overlapping with partially filled conduction band. It is, this is not overlapping. This one also is not overlapping. But in case of metal, is it overlapping? Right? So it will be metal or conductor.
Right.
Yes. Can we move further? Okay, next question says match the crystal structures with the number of atoms in a single lattice?
Much the crystal structure number and symbol.
Simple cubic 1,
Simple
BCC
cubic
2,
is
FCC 4,
1,
BCC 2,
BCC is
SN 2,
2,
FCC
FCC
4.
4.
FCC 4. Yes. Here you can see this is simple cubic. So we have 1 by 8 atom at the edge,
H.
at the corners. Yeah, right. So how many corners are there?
8 core.
8
8.
corners.
So it will be 1. But for BCC we have one more atom in between. So it will be 2. And in case of FCC we have half atoms in 6 faces. So total will be 3 and
3
1
plus
at this corner. So
again
it will be 4.
4.
Yeah, great. So answer is first simple cubic 1, BCC 2 and FCC 4. Okay, next question says choose the correct option. If N type or P type are the semiconductor, so we are doping with N type or we are doping with P type, or we are making them N type or P type. So what will present there, donor level or acceptor level? In what kind of doping there will be a donor level or an acceptor level? You need to find out. Like in case of a P dope, it will be donor or acceptor, or in case of P.
Yes, sir.
If we are doping a semiconductor with N type or P type, so their band gap decreases. We can say there are presence of donor level or acceptor level. So I am asking in what case which level appears?
D.
You are saying B.
D. D.
D. P type
Yeah.
means acceptor level.
Yeah.
Okay. So this is an hint for you. This is the answer for this question, not an hint. You can say for P type, what happens? And acceptor levels appear, right? So D is correct. And in N type, what happens? A donor level appears. So N type for donor. So answer will be A and D. A and D. Okay, so let's move further. So there were 12 questions in your week 2 assignment. I have covered 6 already, and 6 questions are from my side, and 6 questions which are left, they will be taken by other like mentor. You must joining the Rohit sir classes, right? Are you? The classes which is scheduled on Saturday. Are you joining those classes as well?
Yes, sir.
Okay. Then Rohit sir will take other 6 questions. I already took first 6 questions and other questions are added by me. So let's move to the next question. Solar cell works on which charge carriers generated by the incident light?
Minority charge carriers.
Minority charge carriers. Right, correct. So solar cell is a minority charge carrier device. Answer will be B. So next question says, find out the current and voltage output from a parallel combination. Read it carefully, parallel combination. of three solar cells. Means we have three solar cells in parallel combinations. We need to find out the current and voltage of this combination. If voltage of a single solar cell is given 0.6 volt and current of a single solar cell is given 2 ampere. Okay, by saying C. Okay, first let me know. Okay, I'm giving you a hint. Someone saying, yeah, Sandeep Sahu is saying A, 1.8
The answer is a
and
B.
2 ampere. Okay. What about others?
Yes, sir.
A, 1.8 and 2 ampere. Okay. Okay, now I am presenting a hint to you, and then based on this hint, please solve it.
Connection. Series connection.
What happens in a series connections where voltage is additive but current remains same? But in case of parallel combination, voltage remains same and current got added. Now, what will you say? The question is asking for parallel combination.
B, sir.
Yes. Now everyone saying B. Okay, great. Ima first saying C and D, now B. Okay, great. Yeah, answer. So the last question for today's assignment is find out the total resistance of grid shown in figure. I am asking resistance of this figure, this grid. Here, how many fingers are here? Two and one bus bar. So just you need to find out the total resistance of grid. Formula is here. And this L is 5. This L is 5. This L and this width is, this length is 10. Okay.
B, sir.
B. Is it really B? I doubt.
It's A.
A. Someone saying A.
Yeah.
Other also saying A. What about others? Just a simple calculation. I'm saying W width and height for bus bar and fingers are same. And I gave you this length 5 and this length 10. Then you can do one thing. You can see total length. Total length of grid will be 5, 10, 15, 20 and then 30. So length can be here 30. Okay. Then divide by its W and H and multiply it with rho. Just convert millimeter into meter, centimeter into meter. Very simple.
Okay. D. 3.
Yes, sir.
A, right, great.
Sir, A,
Yes,
4.86.
yes. A is the answer. Great. So I hope we are done with this assignment. I'll post this video on my YouTube channel as well, and you can ask question here, there, or in discussion forum. Anywhere you can ask question. I hope you all know the place where I upload these videos. Okay. Okay, Suraj. I'll just give you. Yeah, I have posted the link in chat box. You can go, you can save this link, or you can just check anytime. I'll upload this video after this class, and 2 videos are already updated.